Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 10. We are continuing our investigation of trigonometry. So what we are going to do is take a step back to derive some more fun facts. So in the previous video we derived several reciprocal identities. So now what we want to do is derive what's called the Pythagorean identities. Pythagorean identities. Alright, so for the Pythagorean identities, that's a terrible N. Let's fix that. Yeah, it still looks terrible. Alright. So here's our triangle. Here's our theta. Here's our R. And here's our X and our Y. Now we had stated that sine theta is equal to Y over R. And cosine theta is equal to x over r. So that, then we infer that y is equal to r sine theta, x is equal to r cosine theta. Now when I set up the Pythagorean theorem, we know that r squared is going to equal x squared plus y squared. Or in other words, r squared is going to equal quantity of r sine r cosine theta quantity squared plus the quantity of r sine theta quantity squared. So r squared is going to equal r squared cosine squared theta plus r squared sine squared theta. Now we need to note, so what we did here is we distribute r squared. What we need to note is whenever you write cosine squared or some trig function to some power, you want to write the 2 right here and not over here. This right, so this is good, this is bad. Because this notation here can mean two things. Do you mean cosine of theta squared, or do you mean cosine theta, this entire quantity squared? Which is it? It's ambiguous notation, so don't do it. Whereas this notation will always mean this one here. Okay? So write your answer like this. Do not do this, because in all honesty, if we mathematicians, if we see this, we're going to probably think it's this here, cosine of theta squared. So let's avoid that. Always write cosine squared theta like this, so we understand this. Alright. So notice we can divide out a r squared. We have r squared here, r squared here, r squared. So we have r squared is equal to r squared. I'm factoring out the r squared. So we have cosine squared theta plus sine squared theta. That means divide out, when we divide out the r squareds, we get r is equal to cosine squared theta plus sine squared theta. This is one of our Pythagorean identities. Hooray. So this is the Pythagorean trig identity. Sine squared theta plus cosine squared theta is equal to 1. And it's all based on the Pythagorean theorem, which is why it's called a Pythagorean identity. Now there are two more Pythagorean identities we can discover. So if 1 is equal to sine squared theta plus cosine squared theta, I can divide both sides by, how about cosine squared theta? Why not? So 1 over cosine squared theta is going to equal sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta. So we broke this up, right? Then notice this 1 over cosine squared theta, that's the same thing as secant squared theta. This sine squared over cosine squared, that's the same thing as tangent squared theta. And cosine divided by cosine is just 1. So that means tangent squared theta plus 1 will equal secant squared theta. And that's our second Pythagorean identity. In fact, we'll do the same process here. So if we have 1 plus, let's erase that. Alright, so if 1 is equal to sine squared theta plus cosine squared theta, then we can divide everything by a sine squared theta. So we are just, let's see, right, do that, make that more obvious. We're just dividing everything. So notice 1 over sine squared, that's going to give you cosecant squared theta. Sine divided by sine is 1. Cosine squared over sine squared is cotangent squared theta. There is 3 trig identities right there. So we got sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. That is our 3 Pythagorean trig identities. This was just a quick video to show how to derive those important fun facts. Alright. Thank you for watching this video. If you've been enjoying our content, please subscribe to our YouTube channel. Consider supporting us on Patreon, and thank you for joining the math party. I will see you next time.